Alright, today I'm going to start talking about quadratic functions. During the presentation I'm going to do a few warm-up problems, just a few review questions. So a while ago we learned about whether or not a function is linear, and we learned to explain that. We can tell if something's linear if it is increasing by a constant amount. So on this side you can see the x is increasing by a constant amount of 1. Now in order for this to be linear, the same thing has to hold true on the other side. It doesn't have to be increased by 1, but it has to be a constant amount the whole way through. So from negative 9 to negative 2 is a positive 7, and from negative 2 to 5 is a positive 7. And then we have another positive 7 and another positive 7. So this one is linear, and the reason being is that both the x and y values are increasing at a constant amount. The other thing we want to review today is finding the domain of a function. And actually, for this, they actually give me the domain, so we're not quite to finding the domain and range and reviewing that. But what we're going to do is generate the ordered pairs given this domain. So I'll go ahead and put in negative 2, negative 1, 0, 1, and 2. And then what I can do to find the y values is just simply plug those in. So I'd have 3 times negative 2 plus 2. That would be negative 6 plus 2, which would be a negative 4. Then I do it again with the negative 1, and I'd say 3 times negative 1 plus 2, which is negative 3 plus 2. That's negative 1. Then I plug in the 0. Well, 0 times anything is 0 plus 2 is 2. Then I plug in the 1. 3 times 1 plus 2. That's 3 plus 2, which is 5. And then the last one, plug in the 2. 2 times 3 is 6, plus 2 is 8. So 3 times 2 plus 2, 6 plus 2 is 8. So these would be my ordered pairs: negative 2, negative 4, negative 1, 0, 2, 1, 5, and 2, 8. The other part of review I would like to talk about is stating the domain and range. The domain is the x values, so the domain of this function is negative 2, negative 1, 0, 1, and 2. And the range is the y values, and so it's negative 9, negative 2, 5, 12, and 19. Now I really should say y equals these amounts, and this should say x equals those amounts. Domain is x and range is y. Okay, what we're going to be doing, first of all, is using a table of values to graph a function. So you do that in the same manner you do with your linear functions, where you just take the negative 2 and you plug it in. So what we're really saying we have is y equals negative 2 squared, and the negative is being squared as well, so we get 4. Then we're going to plug in negative 1, y equals negative 1 squared, which is 1. Then we're going to plug in 0, 0 squared is 0. Then we're going to plug in the 1, 1 squared is 1, and then plug in 2, and we get 4. Graphing these ordered pairs, I get negative 2, 4, negative 1, 1, 0, 0, 1, 1, and 2, 4. You can graph any equation that's given to you by picking points and plotting them. That always works. The next thing we'll start talking about is how we want to notice that the graph is not linear. A linear function makes a straight line. This is called a quadratic function, and a quadratic function is what we've been seeing, that ax squared plus bx plus c. Really, it just needs to have the x squared term. So there has to be an x squared term. That's why it says a cannot be equal to 0, because if this was 0, there would be no x squared term. I would like you to know the word parabola. The graph of a quadratic function is called a parabola. Okay, on the next part of the videos, we're going to determine whether something is a quadratic function or not.